this session is essentially an exercise, not really an hands-on exercise, because we are not requested to have a computer, but I will use my computer, my application, and try to drive you through a realistic experience of what it means to turn a domain-driven design into practical experience. So I will be serious this time, so I'll just hats off, because I'm serious. Okay, so the problem we're gonna try to solve is how to effectively create a software model to support a live scoring system for a sport of your choice. Well, actually it will be my choice, because the demo is mine. So the sport is a relatively simple sport, and not as simple as football is. Simple in terms of the business logic involved in the change in the progress of the scoring, but it will be water polo. Water polo is a little bit more sophisticated than football, because it has a replacement of players, faults, timeouts, and of course it has goals. And it also has, compared to football, more period. So the idea is building an infrastructure, building a software model, because in the DDD Blue Book, Eric Evans calls that a software model for the domain. It didn't say anything like you have to build an object-oriented domain model. That was simply the way that people got it. That is the way that a lot of gurus all over the world are still trying to sell themselves as experts, by saying that you have to build an object-oriented model. That is just one possible way. DDD, the Blue Book, simply talks about a software model for the domain. So whatever software thing you can come up with to physically render effectively the domain. And this really brings back the focus on domain-driven design on the understanding, learning experience. So the real juice, the real value of domain-driven design is not much in the classes, in the techniques you use to write your classes, but it's actually in the way you learn about the problem. And the primary way to learn about the domain is through the ubiquitous language. So the exercise in this session will be about trying to create a scoring system, the engine, the core engine for a scoring system. The scenario, the business case for this application comes from real-world experience. I'm a father. I have 2 kids. My son is a water polo young junior player, so I spent at least 3 years every weekend being on the brink of a pool, just watching kids swimming and throwing balls, exchanging balls in the water. So when they have an official match, there is a referee, and the referee spends all the time, all the 40 minutes, walking on the border of the pool as the ball is moved between the 2 teams, and it sanctions players with faults, accepts timeout requests, and officially assigns goals to either team. And that's it. There is an assistant behind the referee that manually on a paper creates and updates the scorecard of the match. So the application, the system I have in mind and try to use as the source of the exercise is to support the referee assistant, that instead of creating manually on a paper the scorecard, can be using this piece of web application, and at the same time every information that is entered into the system through the front end is saved to a database and exposed as a service, as a JSON feed, as an XML feed, to possible other applications offering a live scoring service. But anyway, at the end of the day, as we approach this problem, so how would you let a person, an assistant, to enter into a software system information about the progress of a match? So how to track down goals, faults, and timeout requests of players of a water polo match. Okay, this is the problem. This is just advertising. Be serious, this is Visual Studio. So, I think that at the end of the day, probably all developers on this planet will will think that a class like the one you see, a match class like this, works. It's fine. This class called match, match is a good name because it's a ubiquitous language. We have a match in the real world. We have a class named match. Yeah, we're great developers. Because we are smart developers, not just great, even smart. In the constructor, we initialize all properties. We are serious about development, right? So we want to make sure that when a new instance of the class is created, every property is properly initialized. And yes, this is one of the key things written in the Blue Book. Every object should always be in a consistent state. And yes, so giving to this smart piece of code, every time a new instance of the match class is created, the ID is empty. Team 1 and Team 2 are set to home and visitors. The day of the match is today, by default, of course. The score, yeah, this is a really smart piece of code. New score. Yeah, because DDD says that you don't have to be using primitive types if you have an alternate. So I have a new class called score. And score just puts together the number of goals as integers scored by each team. I'm smart. I'm really proud of this code. Now, the first objection to this code, to the constructor, is the ID set to empty. Does it make sense? It doesn't make sense at all. More. Also, the Team 1 and Team 2 make no sense at all. So, initializing the match, if you want to give the match class an implementation that is business-driven, the first 3 lines of the constructor are total crap. In the real world, championships, any sport, there is no free ID of a match. It's a business that says that. In much the same way, in tennis, real world, again, there is no fancy ID. Every tournament has a fixed ID determined by the worldwide organization behind the International Federation, behind the physical organization of tournaments. You cannot invent your own tournament ID. Okay, you can do that, but you are not really matching the aspects, the visible aspects of the business domain. So now, when you have there's a championship at any level, junior, professional, amateur, there is an organization behind, and the organization schedules matches. And when a match is scheduled, it means that the match has an ID. It can take any form. It can be a number, it can be an alphanumeric string. It has a unique ID. And the names of the teams playing that particular match are fixed. So the first thing we should take into account if we want to create a match that is really part of the ubiquitous language for the real business, a parameterless constructor makes no sense. Because we have a match in the business context only if we know ID and team names at the very minimum. At least ID. But because the model we are going to create must be completely independent from the database, we need to know ID, team, and team names, even though team names are read from the database at some point. But a match is identified business-wise by knowing the ID and the names of the two teams. And then, even the day of the match should be passed. But anyway, we can be flexible on the day, because the day can change because the match is postponed. So let's focus for simplicity on the fact that a match is uniquely identified only when we know ID, team name 1 and team name 2. The score changes. So initializing the score to an empty score makes sense. It's okay, it's good. The state of the match to be played makes sense. Venue and day, they probably, we can be flexible about those things. So this is the first immediate aspect that I want to call your attention on. But there's a lot more to be said about this class. Let's scroll through the content. Yeah, this is all the class. This is a relational class. It's one-to-one with the way we expect the class, the content, the information to be stored on a relational database. Now, is this a problem? It depends. It depends. So not because the class is one-to-one with a relational database, it's a wrong class. The point of domain-driven design, and the point that is summarized in the Blue Book by saying, in your classes, you should expose behavior. Not much property, but behavior. What does it mean, behavior? Behavior means methods. Okay, methods, but which are the methods on a match class? I need to, I need to carry information around a match, and this is the right amount of information. So methods, just to have methods? What does it mean, methods? It means that instead of having public setters, I have set methods, explicit set methods. Oh, in that case, I have methods, but it has stupid, it has this. So what does it mean, methods? Okay, I don't know what a method is, so I keep on going. This class works. It's one-to-one with the database, with a relational table. I can read and say and write through this class any content to and from the database. I can use this class even in a code-first entity framework model. This class is perfect for the purposes of reading and writing the state of a match. Okay, what about the logic? Which are the actions we expect to perform through a match class? I'm a smart developer, and I just added here, and I'm very proud of that, the is-in-progress method. And is-in-progress is it's a query method, and if I expand, you see that it just returns a Boolean whether the state property matches in progress. Okay, instead of using this check explicitly all over the places, I just use this method, which just makes the code cleaner, more elegant, and more expressive. And I feel really proud of my code. I'm really, really, really happy. But there's more. Let me go through the class here, score. Yeah, another beautiful piece of code, because this class, which can be mapped to the concept that in DDD we know has value objects. In DDD, they say that value object is essentially a class you use has essentially a data transfer object as a container of information, typically an immutable container, so whose state never changes, but it's just recreated every time that something changes. But anyway, it's a class that describes an entity we observe in the domain. So we have a match and we have a score. Fine. And the score is the combination of a few individual numbers, like the goals scored by team 1, the goals scored by team 2, the index of the current period, first time, second time, whatever, and whether the ball is in play or not. Yeah. In water polo, whether the ball is in play or not indicates a state of the match that changes frequently, because whenever the referee calls the ball out of the pool because there's a timeout, or because there's a discussion, or there's a goal, or there's an end of period, it calls out the ball, and the ball is not in play. So, yeah. And even if you ever had any experience with live matches in professional pools, there is, when they have a water polo specific lead wall and scoreboard, there is a specific green or red light that turns on and off to indicate whether the ball is in play or not. So it's business-wise is an important aspect to take into account. So apparently this class contains nearly everything to describe faithfully the specific business domain. Great, but now again the question is, how should I expect to work as a developer with the match class? Now consider that there is something called the Murphy law of software developers. You know the Murphy law? If something can go wrong, it will. Now the Murphy law for software developers says something like, if a developer can use an API the wrong way, it will. So don't give developers a chance to use an API the wrong way, because no matter what, he will use that the way you'd never expected. So it's all about to use raw terms. It's all about saving your proverbial rear end when you create an API. Just save your back end, essentially. Creating an API, this is what you are really doing. So whenever you do DDD in a bounded context, whenever you try to build a software model for a piece of a business domain, for a bounded context, you are essentially creating an API. An API for other people, including yourself, to use. And you don't want to leave holes around the API for other developers, including yourself, weeks later, to do things that go and violate the business logic. And there are so many holes in this code through which the simple, basic, silly business logic of a scoring system can be violated. Let's look here. Total goals 1 is saved, described as an integer property with a public getter and a public setter. What does it mean? That if you have you can write code that creates an instance of the match class, and on match class you have access to current score, and on current score you can set total goals 1 and total goals 2 freely, with no control, to nearly any value that is an integer. So it means that -4 to 3 million is a valid score for a water polo match, or for a match rendered through this class. -4 to 3 million is 2 integers, but it's not really realistic, a possible score for our match. So it doesn't work. So you are giving developers using your API a way to use it the wrong way. I mean, the wrong way means the wrong business way, but because we are talking about software, as long as the compiler compiles and no exception is thrown, it's legal code. So it's wrong business-wise, but it's not wrong, technically speaking. So domain-driven design and ubiquitous language implementation is all about making sure that whatever a developer can do with your API is legal from the perspective of the business. And of course, from the perspective of the technicalities of the languages. So the first thing I don't like here is the public setters for total goals 1 and total goals 2. You say, well, but if the problem is negative numbers, just turn integer into an unsigned integer. Okay, it's it mitigates the issue. I could even have a smarter setter that doesn't accept values higher than, I don't know, 100. Okay, I'm simply mitigating the real problem. The real problem here is that this API, even with unsigned integers and a cap for numbers greater than, say, 100, even in this case, I have no control, no logical control on when the value, the property is changed. So it's a property with a public setter, maybe capped, but still a public setter. It means that it can be called at any time as long as I have an instance, a public instance of a class that exposes the property. There's no business logic, essentially. It's just a public field, read-write field. And this is not really in line with the business logic of the specific context. You cannot score a goal. If you focus now on what happens during a game, during a sport match. Okay, a goal is scored, and when the first goal is scored, the corresponding value changes from 0 to 1. And when a second goal is scored, it changes from 1 to 2. It never jumps from 0 to 2 or to 3 or to 5. It's 1 by 1 increment. So, in this case, I can achieve that, but I can also achieve a lot more, which is not business related. Same is said for the current period. Indicates that it's a first period, a second period, and so forth. So again, it's a number that ranges from 0 when the match is not started yet to 1, 2, 3, 4, and that's it. So it can only take any of those 5 values, 0, 1, 2, 3, or 4. That's it. And it ranges from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. That's it. No other options. So again, not through a public setter we can achieve that, even if we cap in some way. In other words, the model we have here, oh, by the way, another aspect, important aspect business-wise, is the relationship between is ball in play and total goals. Is ball in play means that when true, the ball is in play, so the match is ongoing. The ball is in the water, so a goal can be scored. If is ball in play is false, it indicates that the ball is out of the pool. The referee typically holds the ball, so there is no match ongoing. A goal cannot be scored, according to business logic. So you can increment total goals 1 or 2 only if is ball in play is true. So any attempt to set total goals when the ball is not in play should result in an exception being thrown. Open a parenthesis. When you are writing a domain model or a public API, public business API, no matter what, if something bad, if you detect something that goes against the business logic, you should throw, no matter what, period. The responsibility of dealing with the thrown exceptions should be put outside the domain model space. So it's callers, users, code that uses clients of the domain model responsible for swallowing exceptions, handling exceptions, but the domain model just throws, no matter what. And throws specific, detailed information with business information about what went wrong and why. Okay, so to cut a long story short, this class is the perfect example of what some people call the anemic model. An anemic model, feel free to Google for this term. An anemic model is a domain model, it's an object model, in which you have, in which all the classes are like this, made of properties, no methods, or very basic methods, essentially smart setters, but no business logic implemented in classes. So you can call any public method at any time with no logical order, and you use the class just as a container of state information, and you move that around. So from the perspective of an application, so imagine a front end with buttons, goal for team 1, goal for team 2. I push the button for goal that assigns a goal to team 1, something happens, an instance of this class is loaded from some database with the information, with the current score for the match with the given ID, and then I do +1 to total goals 1, and then save it back. But all the logic I can do +1 only if the ball is in play, blah blah blah, and whatever checks I need to run are either enforced by the UI, so the button is not available for clicking if conditions are not detected to be proper for the action to take place, or there is some sort of a calculator, a business logic validator, a business logic engine that takes the instance, takes the input, and determines whether the update may take place or not. So you have a match that enters into the black box, and it exits another instance with the state set according to the known business logic. So the architecture of this black box component is a long list of if statements. If this, do that. If this, do that. If this, do that. That works. I mean, it gives you the power to implement any business logic you like, but the more the business logic is complex and sophisticated, the more requirements are added to the list, the more chances you have to get screwed up at some point and you're totally lost in the web of interconnections between ifs. So this class, I'm not saying that this class is not good. Come on, what's going on? Okay, it's back. I'm not saying that this class is bad, that you should not be using that. But there is a better way that is really, really closer to the idea of a ubiquitous language. So let's drop this, and these classes are in what I've called model old. Let's close everything, and let's bring up another version of the match class. The first thing we notice here is the constructor. The constructor has now 3 required parameters. So I'm no longer allowed to instantiate a match class without specifying explicitly ID and team names. If I expand the code, I see that the 3 key properties are set, and then the state of the match is initially to be played. A new score is set to be the empty score. Okay, venue and day are set to whatever values they are. Current period is now 0, and is ball in play is false, and score now has been simplified, and it just contains 2 values, goals for team 1 and goals for team 2, because if we get it closer to the real business, the period is a property of the match, not the property of the score. And if the ball is in play, is a status of the match, not something that belongs to the score. It influences the score, but it's not an information that belongs to the score itself. So now the first aspect, the first impact this new code has on client code is that I can no longer have a plain var whatever equals new match. I have to know, I must know ID and team names, which makes sense for the business. Because as I told you, in this kind of business, there is a fixed match ID, there is a fixed team names, and there's a part of a calendar, part of a schedule that the organization behind the event issues. So you know them. And because I can only create a new instance of the match if I know ID and team names, I can really guarantee now that whenever I have there's a running instance of the match class, that really references a real match in the database. Look at the commented lines. So these lines are commented for the simple reason, for the simple reason that on this machine I don't have installed extra tools to process code contracts. But anyway, it's just a matter of which API you use to do preliminary checks. Essentially, this is an example of using Microsoft .NET code contracts to essentially throw an exception if a condition is not verified. So you can consider this as preconditions analogous to having an if statement, throwing an exception otherwise. So the way to read this is to run the constructor of this class. It is required that team1 is not null and team2 is not null. You can replace these two lines, if you don't support code contract, with if team1 is null or white space, throw argument exception. If team2 is null, throw argument exception. And now this is a way to enforce business logic. These are business rules. I can create a new match only if I know that team1 and team2 are not null, and of course also ID, which is missing here. If you pass me, if someone happens to pass me a null, I throw an exception because that is not acceptable business-wise. Next. As you can see, with the exception of these two properties, venue and the day, that I told you we can treat, okay, it deserves more thinking, and you know, thinking related to the specific context we are considering. So let's ignore venue and day, and let's focus on the other properties. As you can see, all other properties have a private or internal setters. You know what it means? I can read those values, those properties, but I cannot set them publicly. So anybody who happens to get an instance or create an instance of the match class is not allowed to set the current period or to change the state of the match, at least not through properties. It can read the current state of the match, but it cannot set it. And likewise, it cannot change or set the current score. What? Even the current score? Actually, yes, because the implementation of score now is analogous. Here we go. This is the score class. Okay, it's sealed, so just an attribute that makes the class not further inheritable. It's a way to, you know, to explicitly say that I want this class to be immutable, to be just a container, and either it's like this, or if a new value changes, like, you know, the number of goals, I have another instance, just like strings in the .NET. Constructors, I need to pass explicitly goals. I have two properties, total goals 1 and total goals 2, public getter and private setter. And the only way I have to set goals is the constructor, and then by creating a new instance of the class. So the class is immutable. When I have this kind of classes, I also need to override equals and get hash code. In particular, I need actually to override equals because when you have an immutable type and you compare two instances of the immutable types, you essentially want to make sure that they are judged to be the same if they contain the same data. But by default in .NET, with the exception of primitive types, so integers and dates, when you compare two instances, it's the memory address that is compared. So if they are different instances, they result to be different, even if they contain the same values. So we have to alter the algorithm, the equal algorithm, and return true if two instances of j and other score have the same values stored in total goals 1 and total goals 2. And whenever we override equals, this is plain .NET programming, we also have to override get hash code. Overriding get hash code is mandatory every time you override equals. The algorithm you choose to override get hash code is totally up to you, and actually it doesn't really have a deep impact on any other code you can have, because the only aspect of .NET programming that is impacted by get hash code is when you use an instance of this class has the key column in a dictionary, which is a fairly rare kind of scenario. So unless you plan to use an instance of the score class in the key column of a dictionary, you can even return 0, 1, 2, 3, even a constant value. So the implementation of get hash code doesn't really matter. But if you want to make sure that, that is the key of a dictionary, you want to have unique values, you have to invent an algorithm, and this is just an example. An algorithm that ensures that you have different values for different combinations of values inside of the class. Great. So the fact is that even when now I have an instance of this class and have access to current score, I cannot change total goals 1 or total goals 2. So the question becomes now, okay, fine, I have a nice representation of the match and score classes, a new representation, but the question is, how can I now implement any change of state? How can I really change the score? That is through methods. This is behavior. Behavior. What DDD calls behavior. Yes, but behavior now forces me to think about which are the real actions that in the business domain are performed on a match. And then you start thinking of, okay, what is a match? A match is, okay, water polo match, fine. But I'm using the water polo match object in a context of a scoring application. So which are the things that users need to do? Which are the users of this application? The primary user of this in this context is the assistant of the referee. And the assistant of the referee has to perform actions like starting the match, calling out goals, calling out timeouts, when players are sent off, assigning faults, calling the end of a time, calling the start of a time, and so forth. These are the actions that we must expose out of the match class in the context, in the bounded context for which we are creating this match class. Now, to give you a concrete example of a bounded context and why we may need different bounded contexts, I told you that the entire system, now consider that this project is a part of a class I teach typically over 3 days. And in these 3 days, I build a full system that works as a live scoring system. So there is an app, there's a web front end where users can make progress on a match, and then there is another part of the system that works using SignalR as a live scoring front end. So it's 2 different parts of the system. But now, both parts of the system need to deal with an entity called the match. But the scoring app has a lot of logic because it needs to make progress according to the state of the match. The live scoring part just needs to report the current status of a match. So I don't need any logic in the part that just reads. I need a lot of logic instead, business logic, okay, in the part of the match that deals with the tracking of the score. So they are different bounded contexts in which I have two entities called match here and match there, but they refer to the same logic kind of thing, a match going on, but the representation is different. I need a lot of business logic here, I need nearly no logic there. I still want to call match, but it's 2 different matches. So what should I do? Have a single match class shared that encompasses business logic and just reports? No, I mean, I can do that. But that is the starting point of a big ball of mud, of a starting point of a mess. Because I'm adding too many responsibilities to the same class. I'd better split the domain into 2 smaller domains. Very small, very simple, very basic domains in which I have 2 classes called match. Yeah, but this is duplication. It's the same name. It's not duplication of logic. It's just having 2 classes with the same name and different programming interface and different roles and different business roles. That's it. It's not duplication. It looks like, oh, I don't want to have 2 different match classes. If I have that, I'm not a good architect, I'm not a good designer, and I'm just introducing duplication. No, you are simplifying things. Okay, you are having classes that share the same properties, but with a completely different business goal and business purpose. Different bounded contexts. So, back to this. Back to the match class here. There are 2 regions here commented out, informational and behavior. Informational, this just shows up how nice it could be to have expressivity. I mean, in the first talk and even so far, I made jokes on elegant code, clean code. But code is better if clean, of course, and it's better if elegant. You don't have to use the argument of code elegance to make the wrong architectural choice, to miss business points. But if you can write code that is elegant, do that. By all means, do that. So instead of having checks about the state of the match that result into explicit Boolean checks, why not having an is in progress, is finished, is scheduled? It makes the code a lot more readable. Okay, toString is not is scheduled. Okay, this is read-only. Now, behavior. I have now methods like start, finish, goal, start period, end period. And I can have more. And depending on the events that I want to track down. So you may think that, oh, well, but there's a lot of logic. What does it mean that the match starts? Does it mean that I go to the database and read? No, nothing like that. I mean, I have an instance of the match class that is materialized, care of repositories outside this DLL. The match class is fully defined when it is given IDs, team names, and the initial score. After that, the interaction only happens through these methods. I use these methods instead of, to alter the state, instead of directly dealing with public properties. And the code in these methods is very basic and incredibly clean. Let's start with the start method. Just one line that alters the state of the match. But it gives me the fantastic opportunity to introduce business rules, checks. Okay, what does it mean that the match start? Okay, which are the conditions for a match to start? You can figure out from requirements. You figure out easily that a match can start if the state is not started yet. So you can call start only if the match is scheduled. Or the match start not to throw, it requires that is scheduled returns true. So this means that I get an exception if I call twice start on the same instance. Guaranteed, I get an exception, period. Let me comment out, otherwise demos won't work. Finish is analogous. Just changes the state, but it's obvious for me to check. I can call finish only if the match is in progress, the period is the last one, and the ball is not in play. So the final period has to be called finished for me to close officially the match. And this is another aspect that is business specific. Because in live scoring, whatever sport, there's a match that is called started before it physically starts with the ball in play. There's a warm-up phase. There are many different phases. So when typically in water polo, when even at the amateur level, when the referee shows up, the match is officially open. When the scorecard is open, the piece of paper is started being written. The game hasn't started yet, but the match is open. The period is 0. So same at the end, when the final period is called out, done, current period is, say, 4, but the match is not finished yet. It requires an extra action. What about other methods here? Start period. Let's drop this for a moment. Okay, to start a new period, the match must be in progress and the ball must not be in play. If the ball is in play, so it means there's game going on, I cannot start another time, another period. It would be against the rules, against the business rules. So you see that it's obvious. It comes very, very easy to set and introduce business rules inside of classes. So the real point, the real focus of domain modeling is where you put the business rules. You want to keep business rules in a separate calculator, in a separate magical box? Do that. If you do that, you just need to have classes that represent data transfer objects. And they get into the magic calculator with a state and they exit out with another state, and the magic box guarantees that whatever happens inside, the exit object is in a valid, business valid state. It works. There's no problem with that, except that when the business logic and the number of business rules become numerous and complex and intricate, it's tough to maintain that code. It's a real nightmare. In this way, you are splitting business rules, mapping them to the real business objects that are deeply and really involved with those business rules. So the more you understand about the domain and the logic, the more easily it comes for you to write the real code. And the code you write reflects one-to-one the business entities and their behavior. And more, even the names of how you call things. To finish off this demo, in start period, I just needs to increase current period by 1. Okay, understandably, I can just do current period plus 1, but I use increment, which is an extension method. It's a plain, silly, stupid extension method that does the plus 1 capped to a maximum value, but, okay, it's an implementation detail. If I go back to the match, I see this, and this is descriptive. A lot more descriptive than just a plus 1. It's the same, okay? But it reads much more like a business statement. It looks like a sort of a user story. Similarly, for end period, to call end period, I need to have the ball in progress and the ball in play. I set is ball in play to false, and if current period is the last one, I automatically may decide to call finish. What about goals? Here you see another way to implement preliminary checks, preconditions, without using code contracts. If I call goal for this team ID and the match is not in progress, I throw an exception, can't score a goal if the match is not in progress. Or if I call goal when the ball is not in play, you cannot score a goal if the ball is not in play. And then what you do is just giving a new value to current score, creating simply a new instance of score with the total goals 1 or total goals 2 incremented by 1. So the final point is, even in this very simple, basic example, there is quite a bit of business rules. It's about 20, well, sort of, 10 to 20 business rules for what you consider a stupid kind of thing. But because I wrote in past years an implementation of a system like this, using the approach of the magic calculator, even with 20 business rules, you can easily get crazy. Imagine when it's hundreds or thousands, as in a realistic system. It's crazy, really crazy. So this approach saves time, but it requires a different mindset. And now, what I want to show you is, let me comment this out. For a moment, I also have to go back and on start command, no, what's that? In the constructor here. Let me comment this out because I don't have tools installed on this machine. Let me talk about testing. Here we go. The API allows you to write code like this, which is a true story. It's the story of the match. Okay? You create a new instance, and then you start the match, start the first period, end the period, start the period, score 2 goals for home, end the period, start the third period, score for a visitor, end the third, start and end the fourth, finish the match. What is the score? 2-1. It's not, I mean, this is business. Imagine now that this code is not a simple unit test, but is code you have in your middle tier. And something goes wrong. You get a call from the customer, and the customer tells you, oh, well, when I do this, blah, 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 I get a result that is not what I expected. Okay. You take the call, you go through the code, and if you find code like this in the business tier, you can nearly read the code to your customer and figure out if it's a matter of an algorithm being wrong or just an implementation detail that is wrong. So the logic is, the workflow is correct, so if it doesn't work, probably there is something in the implementation of those methods that looks in some way wrong. But there is more. There's a second unit test here. Now, let me first run unit tests to see what we get. Okay, it works because it failed. Okay, the first test score is correctly set. This test passed, so this test just passed, okay? But this test didn't. And there is an obvious reason, because this test was expecting an exception thrown because I'm trying to start a match, start a period, end the period, and then call goal. So I'm calling a goal has been scored outside a period when the ball is not in play. Okay, the test fails because no exception is thrown. So imagine now you get a call from the customer that says, look, when I push the button score in this, under these situations, he scores a goal, but he was not supposed to score the goal. So what is the problem? So you go there and you say, okay, what I'm doing here is the match is started, the period ended, and the goal is scored. No! You cannot score a goal if there is not a running period. Oh, I got it wrong. Okay, I fixed the code. So you can discuss with the customer what is wrong and what is not, even in case of bugs, just using the ubiquitous language, using the language of the business, and the language of the business is also the language you have out of your classes and the methods on those classes. So the problem here is that in the match class, in the goal method here, I just missed. It was there, but I just commented. I missed this. So if I enable, okay, it means that for the goal to be scored, I also have to check if the ball is in play. And now I save, I recompile, I rerun tests, and guess what? Both tests now pass, because the exception expected is correctly thrown and captured by the unit test. So it's obvious now what is legal and legitimate from the business perspective and what is not. This is, at the end of the day, the essence of using the ubiquitous language in the context of domain-driven design. Thank you very much for your time.